is now good afternoon to everyone who is present in this session. I will be talking about the topic mobile and wireless data science. So I have tried to orient my talk in view of, theme of this particular certificate course, and that is on data science. Initially, I will be giving background about what data science is there, what is the role of data. Then we talk of, you can say, related fields. Today we talk of AI, machine learning, deep learning, and then during later part I will be talking about, you can say, different wireless and mobile technologies, and in between we'll discuss that how these technologies, they are contributing a lot of data, what are the issues in order to address those related, you can say, overheads which are due to high or big volume of data, constant environment in the wireless and mobile communication and computing. And then in between, for those who are doing or interested in doing the research, some pointers related to research, they will also be given. So I think the you can say participants, they belong to heterogeneous group ranging from, you can say, different backgrounds. I hope as per the brochure I saw, it ranges from, say, diploma up to maybe you can say master level and so on. And accordingly, I hope the background may be with the science or electronics and so on. So in between, if you find that I am repeating something which has already been covered by other participants, so anyone can alert me, and accordingly I can skip that portion. Or if someone finds that I am talking of, you can say, something which is not understandable to them, so in that way I can try to correlate and spend more time on that particular portion. So I will start today. If we see the situation, we are making use of information and communication technology. So we are flooded with data everywhere, whether we talk of, we can say, any application, we talk of, we can say, different domains at our home, in the office, while we are walking on the, you can say, path, or we are driving, we are using some resources, maybe online, like banking transactions, etc. So everywhere there is role of data. So issue becomes that how different technologies, different areas, they are governing this data effectively, and how we can use the data as a knowledge, as a resource for better governance, or for, you can say, better quality of. So a lot of data is there. If we talk of even social media, we talk of even scientific instruments, as we talk of different sensor technologies, we talk of radars, we talk of, you can say, different appliances. So a lot of data is generated. Similarly, our mobile phones, laptops, or other computing and communication devices, they are generating a lot of data. Similarly, we talk of today, say, recent technologies like Internet of Things, or we talk of say Internet of Everything. Similarly, we are talking of, we can say cloud computing environment, grid computing. We talk of different generations of wireless communication, say fourth generation. People, they have started talking about fifth generation. So every technology contributes huge amount of data. So we have to accept a challenge, and we have to provide resources in order to handle this data, resources in terms of storage, in terms of communication, as well as in terms of computing. So the progress and innovation is no longer hindered by the ability to collect data, but by the ability to manage, analyze, summarize, visualize, and discover knowledge from collected data in a timely manner and in scalable fashion. So as stated here, nowadays we do have technologies, so we are not, you can say, hindered, or there is no obstacle in terms of collection of data. Data may be collected by different different sources are there, so we can collect data. But how to store that data, how to apply computing, how to you can say communicate that data, how to extract information from the data, how to say derive knowledge from the data, that is the major challenge. So huge volume of data creates the challenge, and we have to find different technologies and techniques in order to handle the issues. So if we see, say today we are using so many technologies, we are using so many, you can say, applications, so many, you can say, different channels for computing, for communication. So we talk of Facebook, Twitter, and so many social media. So everything, every you can say application is generating data, and there are given some figures that how many people or how many transactions are taking, say, per minute. Okay, so if we see this data, we are surprised that there is a lot of flooding of data, many people, they are hooked to the network. So that network should be such that it is taking care of such large number of users. At the same time, whatever you can say data being generated, there has to be some mechanism in order to store the data. And if somehow we have to extract information from their data, so there has to be some provision in order to extract information. For example, if someone is putting some say objectionable comment on tweet or maybe Facebook, later on we want to catch that particular person, so there should be I can say accountability. At the same time, there has to be provision in order to address these issues in terms of maybe governance, in terms of housing. So again, you can see similar message that during the last 25 seconds, so many things have happened over the network. This means you can see we are flooded with information, we are flooded with data. At the same time, there has to be capability with the system in order to address or in order to handle so many users and data. So nowadays we are talking of, you can say, data science. Similarly, we talk of, you can say, different related technologies. We talk of big data, we talk of data analytics, we talk of artificial intelligence, machine learning, statistic analysis, and so on. So these are, you can say, different terms which are either existing for years or some few terms have been coined in the recent past. Okay, though the concept of AI, machine learning, etc., it is existing for you can say last many decades. Okay, so it has attracted say attention of the community, the attention of the researchers, in view of capabilities existing in the hardware. Nowadays we are able to have hardware which has got I can say higher capacities and capabilities, and therefore whenever you can say a lot of data churning or data processing is required for you can say algorithms which are related to AI, machine learning, big data, etc. So these capabilities have made the execution of these algorithms or you can say processes over a large volume of data, and accordingly we are able to use these technologies at present, or the technology has got attention in the recent past. So I will be going through you can say different concepts, like we talk of data science, big data, data analytics. Okay, so some hints are given here. For example, data science is a field that comprises of everything that relates to data cleaning, preparation, and analysis. So here, given huge volume of data, which is which can be taken as part of the big data, so data science relates to applying, you can say, different operations so that we are extracting information which is useful and which is crucial in order to make some strategic planning or decisions. Then different tools are to be used so that we can have some correlation among the data. We can generate some, I can say, trends about the data. So we can apply you can say analytics related tools, so that such tools, they are I can say finding different patterns or different relations among the data sets, and accordingly these data sets can be exploited for deriving the inferences. It has got, you can say, different applications. So another slide also gives similar kind of idea. the world is generating data at a higher rate, and so the need of data science and data analytics increases to analyze and manage this big data. So idea is that big volume of data is there. It has to be processed. Some tools they are to be applied. So tools they belong to data analytics, and you can say different processes or different steps which are extracting useful information after cleaning of data, after processing of data. That is part of, you can say, data science. Now question comes, we are interested in, you can say, extracting some useful maybe part of the data. Okay, so generally there are later terms or counter with the later terms like data, information, knowledge. Okay, so I will be giving some idea about this. Data is, you can say, raw concepts, or you can say maybe something related to numbers, characters, whatever you can say, lying. It may not be so useful unless it is converted to information. So information is say processed form of the data, and volume of data as well as information may be quite large. We are interested in you can say extracting only small portion or summary of the information that is contained in big volume, and that is nothing but the knowledge. So that way we can have, you can say, information from the data, and then information can be processed in order to derive useful summary or abstract, and that is nothing but the knowledge. Some examples are given at the bottom. Say data may be something 100. We are not knowing what this 100 is there. So information may be something 100 miles, etc. So we are associating unit. Then knowledge becomes maybe someone is looking for, you can say, walking or traveling from one location where distance is this large. So knowledge would say that 100 miles is quite a far distance. Similarly, you can say then we can go for wisdom. So here inference can be drawn that it is very difficult to walk 100 miles by a person, and maybe some vehicle is required. Okay, so this is how data is used, and from there we derive information and then knowledge, and we can have some sort of, you can say, wisdom at higher level in order to give subjective description of the knowledge. Then related terms, we talk of AI, artificial intelligence, machine learning, you can say deep learning. So some brief description. We talk of AI, engineering of making intelligent machines and programs. Then machine learning, ability to learn without being explicitly programmed, and deep learning, it makes use of, you can say, multi-layer neural networks. So message on the screen is that AI, so given some input similar to, you can say, whatever you can say, processing done on any input by the system or by the computer. So it has got, you can say, similar kind of architecture, but it depends upon what is the input, how the input is processed by the program or by the hardware, and accordingly output is generated. So maybe some data is there, according to that we are generating some actions. Then sensors may be there which are generating input, and accordingly some movement may be there. For example, maybe in terms of a robot, etc. So sensors, visual sensors are there which are capturing some information of the environment, and accordingly robot arm or robot may move from one location to another. So similarly it may be some image, and accordingly we can generate some text. For example, on Facebook we have, you can say, different photographs, and system has capability to tag these photographs with the name of the persons or with the name of the location or event. Okay, so that comes the intelligent behavior of the system, and that different images are taken, and accordingly they can be tagged or they can be categorized, or some other actions as per programming skills can be performed. So of course, when we talk of intelligent system, so they should be able to learn from experiences. They should be able to process large amount of data. There should be tolerance for the errors, and to handle some ambiguity. In some cases, we require that you can say responses, they should be generated faster. For example, if you talk of robot, so if some obstacle is coming, so robot has to react accordingly. So reactions, they are almost in the real time. And requirement is that they should be able to communicate with humans, maybe using natural language, whatever you can say understood by the human. It should not happen that the machine is always, you can say, communicating in a language for which some expert is required, or maybe it is not communicating only in English. Nowadays, we have examples, even working example of some prototypes where communication can be done in natural language like Hindi or any regional language. So it has got, you can say, different applications. So just idea. So it has got, you can say, applications related to vision, to speech, then natural language processing, etc., etc. Okay. So if we put everything together, so this is how you can say these different fields, they can be related. So data science has penetration to artificial intelligence, machine learning, to deep learning. In overall, I can say AI is the broader area. It has, you can say, subdomain as machine learning, and within that, a subdomain is there that we call as deep learning. But data science is the broader area, which you can say includes even AI. So we'll say that to some extent, data science is the area which is a superset of all these fields, whatever you can say, recent we can say technologies or different fields we are talking of. So data science includes everything, consisting of AI, machine learning, deep learning, and even you can say because it is related to processing of big volume of data. So big data is also subset of this, and accordingly, different tools which are used as part of data analytics, they are also part of the data science. So data science is some sort of superset consisting of, you can say, different fields, including even database management system that we traditionally study during our, you can say, engineering or otherwise other courses also. So maybe the terms, they are not new, like AI was introduced in 50s, then in machine learning in 60s, and then deep learning in 70s. So some, you can say, background they do have already, and maybe the courseware or the technologies, they were being used in 80s as well as in 90s also, but it could not become popular because of overheads in terms of computing and communication requirement. So nowadays we do have powerful machines in order to process the data. At the same time, we do have, you can say, different latest say networking strengthening in the technology, whether we talk on wired front or we talk of wireless technologies, so we can communicate huge volume of data from one location to another location, and therefore it is possible to have these technologies in you can say practical shape, or in, you can say, shape of the products at present. So when we talk of, you can say, maybe data science, and if we talk specifically about machine learning, so there nowadays we are interested in the classification of data. So it may be based upon already known classes. For example, if we have to categorize, you can say voices of different participants or different people, and already if we do have samples of, you can say, different users, so we can classify that this particular voice belongs to user A. Similarly, next maybe clip belongs to user B, and so on. Okay, so that is called supervised learning. Here we already know that these are the well-defined classes, and when number of classes they are not known, some new sample is coming or new test data comes, so we cannot classify it into already existing or known classes, so that becomes unsupervised learning. Similarly, it may be a reinforced learning where some feedback is required, and accordingly thereafter we have to go for, you can say, control based upon that feedback. Okay, so some more details about machine learning. So this we can skip. Then we have, we can say, deep learning. So deep learning, as I told previously also, that deep learning makes use of you can say multi-layer uh, uh, neural networks. So maybe at different layers, we are doing some refinement in the outcome. For example, given some different faces, we do want to have, you can say, face recognition, or we want to apply some segmentation, that is division, or you can segmenting the given input single image into multiple images, so that every sub image contains a single face. So we can apply edge detection algorithm at first layer, then maybe second layer, some you can say features they are extracted. At final layer, we do have, you can say, maybe individual features they are obtained. So that way, you can say multi-layers they can be applied, and accordingly we can have you can say refinement at every layer, and finally whatever you can say expected outcome, it can be obtained. So some examples what AI can do. For example, given input is post picture, so we are looking for are their human faces. So whether human faces are contained. So application may be used in photo tagging, as it may be related to Facebook, it may be related to, you can say, other social media applications at present. So either then output has to be 0 or 1. If it is it contains the human face, it will be say 1, otherwise it will be 0. Similarly, maybe some profile we are trying to study. So loan application, will the person repay the loan? So maybe based upon the profile of the person, we can derive some inference. Similarly, there may be some advertisement and user information. So whether the user will click on that information, so we can have that kind of idea, and based upon that we have applications. We see that depending upon the, you can say, profile or context of the user, you will be given you can say different advertisement on your browsers, on your, you can say, social media platforms, and so on. Similarly, other applications are there. The last one is car camera and other sensors. So it will be giving position of other cars. So we can go for technologies like vector ad hoc network or intelligent transportation system. And applications are there. We talk today as self-driving cars, or we talk of intelligent transportation system. We talk of vector ad hoc network, and so on. Okay, so we can use in different domains, but we have to remember that everything is based upon data. So larger the volume of data, maybe we are getting, you can say, better results, but at the same time there is expectation that the data should be, you can say, free of noise. It should not happen that we have, you can say, big volume of data, but that data is not relevant. There is, you can say, noise with the data. That is, it has got a lot of irrelevant information. In that case, we have to define, we have to pre-process the data, and accordingly we have to, you can say, train our systems. And if training is done with the larger volume of data, and that data is clean one, it is suitable or most suitable as per the requirement of the domain, as per the requirement of the application area, then we can expect better results. So given this background about, you can say, data science, big data, data analytics, then say AI, ML, DL, and so on. So what has data got to do with it? Okay, so when we talk of, you can say, these different areas, so in the machine learning world, data is everything. Okay, so if we talk of AI, and specifically if we talk of machine learning, so they are based upon data. We are training our systems based upon data. So if we talk of data, so we have to keep in mind that no data strategy, it will lead to poor quality of data. So we should be clear what kind of data we are requiring. We should not capture data which is not so useful or which is not relevant. So therefore, we have to plan properly that the data has to be relevant one. At the same time, we have to decide even about the sampling rate, that how frequently we have to capture the data. For example, if we talk of maybe nowadays technologies like IoTs or wireless sensor networks which can be deployed in the field, we are looking for some information, or we are looking for some strategic planning. So we should be clear what kind of application we are looking for. For example, if we talk of maybe some surveillance system, so this should not happen that every you can say 2 seconds we are capturing say data, because it won't make much difference. So maybe data will be captured only if some event is occurring. If we talk of, you can say, surveillance or visual capturing of data. And if we are talking of, you can say, something like suppose we have to study the temperature variation in particular field, then even there will not be much variation after every 2 seconds. So maybe we have to capture one sample every 30 seconds or maybe 48 seconds and so on. So therefore, we have to plan as per the requirement of the field, as per the requirement of the application. Now, if we do have, say, poor quality data, it will lead to ineffective decision or ineffective AI. So therefore, we have to keep in mind that what data we are looking for, they should be relevant, and accordingly, if the data is relevant, it is clean, then it will give us better results. So a lot is happening in the world of data. At present, the data is being generated, as I gave, you can say, a few examples of social media. But if we talk of even physical deployments, a lot of data is being generated. We talk of wireless sensor networks, we talk of say cloud environments where different users, they are subscribing to the services on the cloud environment. We talk of, you can say, security domain where blockchain can be used, or maybe some other techniques are being used. Or we talk of techniques related to data mining. We talk of say data lakes and so on. Or even we talk of, you can say, business domain, or we talk of, you can say, transportation domain. So a huge volume of data is being generated. So there is flooding of data, and we have to devise technology. At the same time, we have to be sensible that where to store the data and what data to be stored. It is not required that everything we are storing, just we have to store only the relevant. Okay, so just a idea on the screen that how volume of data is, you can say, expected to grow in coming years. Fine. So maybe you can say it is some sort of exponential growth. This means huge volume of data is being generated, and we have to handle this huge volume in terms of storage, in terms of processing, in terms of communication, and so on. Now, if we want to specifically talk about say wireless and mobile environment, so this slide gives some idea that there are, you can say, different trends where explicitly we talk of, you can say, wireless and mobile domains, or they are related domains. For example, if we talk of big volume of data or big data, again, even these areas, like we have wireless sensor networks, so different sensors, they are generating volume of data, and volume may be such that it may lead to, you can say, big data. At the same time, you can say data may be generated through different channels or from different sources. So when we talk of big data, it is not necessarily, say, the volume, it is also the variety, that is heterogeneity of data, that also differentiates it from conventional data, so that it has, you can say, got different types of data. For example, data may be generated from some conventional sources in terms of well-structured data, maybe in terms of relational tables and so on, but it may be generated as through social media, as a plain text is there is no structuring. At the same time, multimedia, whether images, audio, video, they can also contribute. So this big data is nothing but it is combination of structured and unstructured data, not necessarily it is huge volume. Fine. Even volume may be less as compared to conventional data, but the difference is in terms of you can say heterogeneity, that is, it contains non-structured data also. Okay, so that is the difference. Then we talk of you can say different varieties of devices. So these varieties of devices, they contribute. Today we have, you can say, so many devices. Even individual user has got maybe 3-4 devices on average for purpose of computing, for purpose of communication, and so on. Maybe as a student, someone has got, you can say, a laptop, then mobile phone, then maybe someone may have, you can say, 2 mobile phones, some desktop or other computing device in the laboratory, and so on. So that way, you can say, different users are having varieties of devices, and data is sometimes even duplicated. Otherwise, also the volume which is created is quite large, and therefore there is flooding of data. Then we do have, we can say, networking scenario where we can talk of, we can say, wired communication. We can talk of, we can say, latest trends in, you can say, wireless technologies. We have, we can say, latest maybe Wi-Fi, WiMAX, or other technologies which are effectively providing bandwidth in order to communicate data from one end to another end. Similarly, resources may be available on the cloud environment where data can be stored and it can be subscribed as per demand. Okay. Then we have, you can say, deployments like sensors, and then IoTs may be there, which has got sensors as well as other technologies, even vehicles. Even you can say non-electronic items, they are also part of the IoT at present. Okay, so putting everything as a, you can say, single part of the or integrated part of the technology, messages that we are having, you can say, different technologies, they have to integrate, they have to work in integration with each other, and they are contributing a lot of data. But there are issues that there is no single ownership. No one is, you can say, owning this technology. So a lot of openness is there. Lot many security issues are there. So when we talk of, you can say, handling of data, we talk of data science. At the same time, security is also equally important, because the information of the user is, you can say, flowing over the network, which is not owned by anybody. Okay, so therefore we have to ensure that how security, how privacy of the data is maintained. So when we talk specifically about wireless world, some predictions are there. Maybe by the year 2020 end, 1 billion computers, 10 billion appliances, 100 billion sensors, and so on. So you can say, idea is that a lot many computing and communication devices are becoming part of the network, and these devices are contributing a lot of data. Even today we talk of, you can say, new appliances which were not expected maybe whenever, you can say, this kind of prediction was made. For example, we talk of devices from like Amazon, Alexa, etc., which are considered as intelligent kind of devices. So these devices, they are connected through Wi-Fi to the external world, and whatever, you can say, command you are giving based upon I can say processing of data, it will be responding to your commands. If you ask to play some music, if you want to do some other activity, so it will be reacting as per the data which is available at the background. Okay, so the training is being done, and at the same time it will be responding. But there is a lot of, you can say, requirement in terms of bandwidth, because it has to always connect to the external world or to the data sources as well as to the you can say servers, in order to provide the connectivity and to respond to your queries. So some idea that how over the years, you can say, trend of computing has changed. Earlier we used to have larger computers. Nowadays we do have, you can say, laptops, we have, you can say, smartphones. Then we talk of sensor technologies where you can say sensor nodes are used, and these sensor nodes are very small. You can say devices may be of the size of some matchbox, or maybe even of the size of a dollar. So this kind of device has got computing as well as communication technology. The scenario is changed because in earlier days the user need to move near to the machine in order to do some computing. But in case of sensor networks or sensor nodes, the deployment can be done in the physical environment, and no need to the user to move in that physical environment. Data will be captured by such sensor nodes. It will be, you can say, sent back to the premise of the user or to the control center, where some decisions or processing of the data or extraction of knowledge from the data can be done. So that way, the scenario has changed. Maybe there are some scenarios. We'll talk of some applications later on. Okay, so again, that over the years, how we can say computing trend has changed. Earlier, we used to have, we can say, centralized computing, where this mainframe or supercomputer used to be there. Then came distributed environment, internet. Then maybe earlier decade, we talked so much about mobile technologies. And today we are talking of, we can say, something ubiquitous computing. We talk of IoTs, we talk of, we can say, cloud environment. So there is a lot of research in terms of maybe BLSI, in terms of hardware, in terms of communication. So that is the reason that today we are talking of, we can say, fifth generation of wireless communication. We talk of, you can say, a lot of data processing capabilities with the machine because of BLSI research, and so therefore this is the kind of trend. And if we talk of cloud computing environment, more or less it is driven by commerce also, that is business, and the trend is similar to, you can say, centralized environment to some extent. So it is combination of distributed as well as centralized environment. So rather than, you can say, getting a new trend, we are something revolving in a circle. So this is how the technology at present looks like. Okay, so any device we are using, it is expected that they should have, you can say, multifunctional capability. They should be able to connect, you can say, at any location, anytime, and of course available with anybody. It is not, they should not be, you can say, costly device, so that you can say society or the community cannot afford it. Okay, and today we are talking of something, anything that is, we talk of in terms of IoT, even such kind of capabilities, they are expected with non-electronic devices. Then we have, you can say, AX at present. So within campus, we can connect through our mobile phones by using such Wi-Fi interfaces, or even laptops will be connected through that. Okay, then if we are part of, you can say, BiMAX, then we'll be connected by using 802.1116 technology. So therefore 4G's culmination or convergence of different technologies. It is not a single technology, and earlier technologies, they were single. For example, 3G has nothing to do with 2G, though devices and technologies back compatible, but it is dependence upon 2G. But in this case, it is dependence upon previous technologies also. Then we have started talking about 5G, where just we can assume that we have, we can say, large or huge pipe of bandwidth available. Okay, so whatever you can say possible at present over the wired network will perhaps be possible over wireless network. Well, if we want to have connectivity at present, strong connectivity, then we go for, you can say, wired backbone. Even our voice, our data, if we even at present part of 4G, so data from the handset, whether it is mobile phone, PDA, laptop, will be carried to the, say, up to the tower or microwave tower by using wireless communication. Thereafter, there will be strong, you can say, backbone of optical fiber. So from optical fiber, it will be connected to the control center, MSC, and the different MSCs they are connected, and it will be to other side of the you can say strong pipe of you can say wired connectivity or backbone. There is no technology at present which can replace existing wired technology. So optical fibers they have to continue. Okay, but at the front end we can have strong connectivity. So researchers they are trying to equip users at the front end and the technology at the front end to provide you can say huge uh, bandwidth so that data can be carried from user end up to the wired point, and from there deliver to other end. So maybe services like cloud computing, etc., even they are expected to be available on so you can say by using technology. Then this is a slide that talks about vehicular ad hoc network. About ad hoc network, so different devices they can form a network that is called ad hoc network. Now, instead of you can say node or networking device, if it is a vehicle, so we can form a vehicle as a network, and they will be called as vehicular ad hoc network. So already technology has got attraction, and there is a IEEE standard called 802.11p, which has uh, uh, mature technology, and people they are working, they are utilizing applications to form what we call as intelligent. For example, drive from point A to point B, I don't know the traffic scenario, and then the vehicle seconds information to my vehicle on the dashboard. There will be message, okay, this route has you can say traffic jam, so alternate route. Similarly, if some accident occurs, then data can be transmitted to the hospital, to ambulance, and precautionary measures can be initiated. At the same time, even vehicles they want to share some infotainment data like movies, etc., or cricket score on the move. So no need to you can send a request to the faraway server. Maybe one vehicle has downloaded the latest frame and it can be shared by others. So that way it has got you can say different varieties of applications. Generally, three layers of three levels of applications are there in the literature, and people are using this kind of technology. Maybe in the future we have technology like uh, you can say self-driving cars, which is part of also this technology. Then we do have technologies where if particular vehicle is changing the lane very frequently, then alert will be generated. Or maybe if the driver is feeling some dizziness, then you can say alert will be generated. Or if a driver is not attentive, then again I can say some alert maybe to the home of the driver or to other persons whose mobile number will be sent. So that way it will be assisting, I can say, the drivers, the transportation in effective way. So maybe this technology will be there in the you can say coming future, and some refinements or some applications we are seeing over the years, or you can say there is some utility that even we can find at present. Now, if you are talking of this kind of scenario, now you see what is happening at the background. A lot of data is being generated. If vehicle, they are part of the network. Now, if you have idea about the networking, then how to make vehicle as part of the network, because in order to put any device as part of the network, some IP address has to be already we have exhausted IPv4 protocol stack. The version 4 of IP protocol stack is already exhausted. We do not have sufficient addresses, and maybe we are talking of millions or billions of the vehicles on the highway. So how to assign addresses to these vehicles? Similarly, huge volume of data is generated. So how to take care of this data? So there has to be a mechanism to store the data, to process it effectively, to extract knowledge or a summary from the data, and so on. So therefore, data science is, you can say, of the concern in this domain also. So therefore, we have to think of technologies highway and so on. So already you can say in the literature you find that roadside unit kind of infrastructure is already there in the literature, which will or which is expected to be part of the deployment in the future. And to some extent already some deployments are there. That is the reason we are getting, you can say, response to the location based queries. For example, while driving on the highway, we can send some query that what is the location of the nearby petrol pump. Okay, so depending upon my location, the response will be obtained. Suppose I am 5 kilometers away from that particular location, then response will be different. Similarly, if I am looking for, you can say, some complex query that what is the location or what is the nearest hotel where I can find this kind of food or this kind of rooms and so on. So the response will be differing depending upon the context. Okay, so such kind of facilities are already existing. Similarly, this is a technology that will be attracting the future business. For example, today we don't have something, you can say, wireless intercom kind of facility. Suppose I want to make a call to my friend or to colleague who is available even 100 meters away from this location. So the call will be routed for the service provider. Can we have, you can say, Wi-Fi enabled voice call facility, something like intercom? So maybe this kind of technology where we will be effectively making use of indoor and outdoor access points, so that strong mesh kind of network is created. So such kind of technologies, they will be assisting the user, and you can say it will be much cheaper as compared to maybe some companies they are working where rather than at software or application level, hardware level, you can say facilities for intercom call, etc., will be available. So already we have voice over IP available on, you can say, maybe at the application layer available, but how to make it available at, you can say, lower layers. So that is the challenge, and that way no need of, you can say, having something or routing of call through the service provider. Okay, so this is a technology that is, if you read in literature, we talk of voice over Wi-Fi. But again, if you talk of, you can say, scenario, lot many devices are there, huge volume of traffic is generated. So how to take care of this? Similarly, we do have wireless sensor network. Maybe here a miniature devices, as I told, maybe of the size of dollar or matchbox, have got capability of computing and communication. So we can deploy such devices in large number in order to have a network. That network is called wireless sensor network. Now there may be different, you can say, application domains. For example, application domains may be something, you can say, you want to study some say, or monitoring physical or environmental conditions such as temperature, sound, vibration. So we can deploy such kind of sensor nodes. Now suppose you want to have some prediction of a landslide, or over the hills we want to have some prediction of snow avalanches. Okay, so how to use this technology, or how to use sensor network deployment for the purpose? For example, we at NIT Hamirpur completed a project for DRDO. There is a special lab called SASE Snow Avalanche Study Establishment, which takes care of, you can say, prediction of snow avalanches. So existing technology was that there was, you can say, some earth station, which is a stationary one, and data will be captured by that earth station. There is no mechanism to transmit the data from earth station to the control center. So some person physically will move near to the earth station to collect the data, and such deployments, they are in very harsh environment over the hilltop, and if some storm is there or the environmental conditions are not favorable, it is difficult to collect the data, and accordingly we cannot predict. But we have proposed them, and they have done it, or they have physically deployed it. Sensor nodes, they will be studying, you can say, conditions of temperature, pressure, then you can say some slight movement of, you can say, layers of the snow, and so on. So different factors they are considered, and data will be captured by sensor nodes. So data can be sent by using some you can say 4G kind of interface to the control center. No need to physically, you can say, move from some location near to the earth station. Okay. And also there is distributed kind of environment. So earlier technology was, you can say, single bottleneck. Uh, like if something goes bad with the earth station, everything is gone. But in this case, it is a distributed environment, and data can be captured by different sensors. So technology is being used for capturing and accordingly the prediction. So almost they are making the predictions to the better accuracy, and that way it is helping the nation and the society. Similarly, you can say other areas may be there. For example, we want to study carbon monoxide pollution rate near to some locations. It is not possible to deploy human there or some other kind of sensor to capture the reading, because the gas is dangerous. So therefore, we can deploy sensors, and that technology will be capturing the data, and it can be sent to the location, and we can study what is the pollution rate. Similarly, can think of, you can say, technology being used as a, you can say, maybe boundary between two parts. Okay, we can assume it to be boundary between even two nations like India and Pakistan. So that will create some sort of virtual fencing. Even at present, the government has targeted to go for, you can say, multi-layer security rather than, you can say, maybe physical. They are going for surveillance based, they are going for, you can say, thermal imaging based, and maybe in the future they will go for this kind of virtual fencing, so that infiltration, etc., that can be studied. Okay, so it has got a lot of applications. Even that how auto washing depending on commercial level low given threshold. Well, and as okay, so I was talking about IoT. So here you can assume that we are putting things as part of the network. But as I quoted that in order to make different things or devices as part of the network, there is requirement of, you can say, how to address different devices. Similarly, huge volume of data is generated. There is also heterogeneity in terms of hardware. For example, mobile phone is different than sensor node, than say laptop, and similarly from workstation server. So there is heterogeneity at hardware level. Similarly, heterogeneity at operating system level, then at application layers. And so therefore, how to combine everything together is challenge. And if we are talking of, you can say, putting everything as part of the network, lot of data is being generated. So how to address the requirement of this data in terms of processing, in terms of storage, etc. So here you can see we can put electronic, non-electronic objects as part of the network. Maybe in the future we can assume something that every chair in the classroom is part of the network. So before starting to the classroom, I can find how many students have occupied the chair, so that I can see if the strength is sufficient, I can move to the classroom. Okay. Similarly, if our train is there, so if a train starts from a particular station, whether the berth has been occupied by the person or not. So maybe at next station, we can identify that these are the berths which are reserved from previous station but have not been occupied. So they can be reallocated to some new requesters, and accordingly we can earn the revenue. So that kind of application we can see or perceive in the future, rather than, you can say, putting some devices or electronic devices which are part of the network. So already some applications are there where even electrical appliances, they are part of the network. For example, we can have smart bulbs, smart LED tubes, or even smart fans, ACs, etc., which can be connected to the network through Wi-Fi interfaces. And maybe before starting from my office, I can give the command that to switch on the AC. So automatically it will switch on the AC. Even that kind of facility is existing at present. But you see that, what is the role of networking? Now data has to move from my location to the my home, where AC has to be switched on, or I want to put refrigerator off, then there has to be command. If connectivity is not there, then we cannot, you can say, transmit data. So we have to ensure that connectivity is there. Now huge volume of data may be generated. For example, if you talk of multimedia data, then that has to be transported from one place to another. Now if data has to be transported, bandwidth has to be provided. So we have to ensure sufficient bandwidth is there, and we have to talk of mechanism through which we can reduce the volume of data. So people, they are working on issues like how to aggregate data. For example, if data is coming from 100 nodes and we want to transmit data further, is it required to transmit, you can say 100 packets, or we can serve with packet? For example, if you are looking for average temperature, then rather than you can say sending, you can say all the temperature values which are sensed by 100 nodes, it can be sent only the single value after finding out the average. So we can apply some data aggregation technique, whatever we do in the conventional database management systems. Similarly, suppose we are looking for, you can say, some visual sensors where scene has been captured by, say, 20 cameras, or you can say 20 sensors which are having, you can say, camera related facility. Now, is it required to send all the 20 images? It will be eating a lot of resources in terms of computing, in terms of communication. So maybe we can identify the best photograph and only that will be sent. So bandwidth requirement will be reduced by, you can say, factor of 20. Okay, so that way we have to identify that what are, you can say, different issues. So there we can go for something like, those who are interested in such kind of research, we can go for entropy based techniques. Just we can identify that out of so many given photographs, which one is the best. Similarly, we can go for, you can see, video clips and audio data, so that we can generate best out of the available data sets, and only that that will be transmitted. Okay, so due to paucity of time, I will not go into detail of IoT. I have given you some idea that just we will be connecting everything as part of the network. So if everything is connected, there has to be mechanism in terms of addressing, and there has to be, you can say, provision in order to handle the data, or you can say technology or some processes in order to address the requirement of, you can say, huge volume of data. Okay, so even in IoT, data will be captured, it will be transmitted, processing. So there is data that way, it will be a combination of structured and unstructured, which leads to what we call as, you can say, big data. So there comes the role of data science. As such, also, if we talk of, you can say, wireless sensor network or IoT, so different nodes, they can contribute data. Now they will be acting as data source. There is replication of data. So this becomes a distributed database environment. Those who are working in the area of distributed environments, they can perceive to be a distributed environment, and there are a lot of research challenges. So these research challenges, they are to be addressed in order to settle the issues, or in order to make IoT more effective, more application oriented. Okay, so in addition to other challenges, we do have, you can say, security related, because data anyway has to routed through the network. So network is not owned by individual. We cannot ensure that this network takes care of our data. So maybe we have to go for strong encryption, decryption techniques, so that there is no threat to the data. This is the message where different you can say devices, in addition to IoT, then we have smart TVs nowadays as one of the domains, PCs, tablets. So everything is contributing to the traffic. So a lot of data, and the growth of data is exponential. Okay, so I was talking that how to make everything as part of the network. So there is requirement of IP addressing. So already we are aware that IPv4 protocol stack is exhausted. We do have, you can say, 2 raised to power 32 addresses. So maybe IPv6 protocol stack is the remedy. So rather than 32-bit address, we go for 128-bit addressing. And this slide gives you idea that how many addresses are there. Okay, so lot many addresses are there, and some just comparison. Just you can spend a few seconds over reading this slide and see that how many addresses are there. This means we do have huge capacity, and therefore whatever you can say requirement of large number of addresses, whether we talk of transportation system, we talk of IoTs, we talk of other wireless technologies, at least addressing part is uh, uh, you can say handled, and we do have already technology. So we have, you can say, technology which is already in place, both in terms of devices, in terms of protocols. Okay. So addressing is not an issue. So we can address different devices, even vehicles on the highway, they can be addressed. So there is a lot of address space, and there is no issue of, you can say, assigning unique identity to the devices. Even chairs, tables, or everything at house can be assigned. So you can assume that if it is possible to make them as part of the network through some interface, then sitting at remote location, we can find out the status of the device, or we can switch it on, switch it off, and so on, whatever you can say activity it can do. For example, if some IP-based camera is there at my home, sitting at remote location, I can pan it, I can tilt it, I can zoom, and similarly, if maybe camera is fitted over the robot, I can command robot will be visiting different parts of the room, house, and accordingly we will be getting, you can say, information sitting at remote location. So over the years, if we focus upon the technology, there is substantial progress in terms of, you can say, computing, in terms of hardware, in terms of bandwidth also. But if we talk of battery power, you see the line is not so, you can say, uh, rising in terms of progress of the technology. This means hardware support is not so progressive, and hence we have to go for different software techniques. So that is the reason we go for, you can say, different energy efficient algorithms. And maybe this is the reason that rather than multi-core, rather than, you can say, having the devices which operate at the speed as per Gordon Murray criteria, that speed doubles every 18 months. So we are going for multi-core architecture. So maybe during the last 5-7 years, multi-core devices are seen in the market because of the reason that we have to make devices energy efficient. Whenever there is requirement to put single CPU on, only one core will be on. Otherwise, if we have, we can say, a single core operating at high speed, it will be consuming, you can say, energy, and the system will not be energy efficient. So this is again, you can say, bigger domain of research, but just we can have broad idea of demand, we can put the devices on. And we can save energy. So this gives just to the upper layers, we can put maybe at higher layer we have data centers or servers. In between we have some you can say storage and processing capabilities. At a lower layer we have, you can say, different wireless devices, maybe sensors, the overall accumulated effective having superset of the data. So just we can have, we can say, that technology. Similarly, data which is now reduced in volume can be transmitted to you can say data centers for processing. From their data, whatever you can say results obtained, they can be sent back to a middle layer, that is edge layers, to the, you can say, maybe the layer which is lowest one, that is things layer. So IoTs or similar technologies like you can say wireless sensor networks, there has to be convergence with big data, or they have to handle the big data. Okay, so we have seen that how huge volume of data is generated through such kind of technologies. Now IoT comprises not only, you can say, maybe sensors. This comprises of our mobile phones, this comprises of smart TVs available at home, this comprises of transportation, our cars which are moving on the highway. So huge volume is generated. So this huge volume, this also comprises of social media. So there is huge volume of data which has to be addressed. Find the layers or intermediate levels by applying in-network techniques, by applying techniques which are more suitable for this volume of data, maybe some data compression techniques and so on. So that way we can reduce the volume to be transmitted. So therefore bandwidth requirement can be reduced. Efficient, the volume of data to be transmitted, to be stored can be reduced, and therefore we can apply different data science techniques available in order to make the overall system more effective. So this gives some idea that how at different layers, while moving from say lower layer to higher layers, we can apply the devices we are looking for. They should be efficient, they should be, you can say, more attractive. So therefore such kind of characteristics, so you can say better quality of data, and these are, you can say, different operations which can be performed for better quality. Now I give you some idea that okay, data is one part. Whenever we talk of any networking, we talk of any, you can say, technology, objective is, you can say, giving correct results, fine, but still there are some you can say threats over the network whenever data has to move. So of course there will be some scenario like these people, they will be smelling the data, that is they are trying to sense what is being transmitted, and hence we have to be sensible. You can focus upon this side. On the internet nobody knows you are a dog. On the other side, what is happening, for example, if on the Facebook you have created an account and you are on the friend list of others, you are not aware who is the person on the other side. Okay, so we have to be careful that what messages we are exchanging, we should be sensible. We should not, you can say, whatever comes to our mind, we should not be something volunteers in writing anything on the you can say such open domains. So we should have awareness about that. That is the message. And when we talk of particularly about wireless environment, so they are more prone to threats, fine, as compared to wired counterparts. So we have to keep in mind that whenever we are connecting through wireless environment, they are more prone to failure, because when we talk about wireless networks, different issues are there, like accidental association. For example, if I keep my Bluetooth or Wi-Fi always on, it may and put it in auto connect mode, it will lead to some chat and maybe as per unawareness of the user. So if we are aware user, whether we talk of wired network, we talk of, you can say, any kind of network, so we can save our data, or we can secure our data from the threats. Similarly, maybe 15% they are undetermined, and similarly 6% are due to that particular Android counterpart, because not many patches they are available, and not many such tools are allowed by Apple devices to be installed. So that way maybe around 79% of the problems we can avoid if we are aware user. Okay, so sorry. Whole idea of my talk was that to create awareness what data science and related fields are there, then how different wireless technologies they have evolved over the years. Now if we are talking of, you can say, these technologies at present as well as in the future, so they will be creating huge volume of data. So how to talk of, you can say, different conventional and non-conventional techniques in order to store the data, in order to address the issues, keeping in view the underlying technology. For example, if we talk of sensor networks, we talk of IoTs, we talk of maybe regular networks, then they have their own constraints. In view of these constraints, how to use the algorithm. For example, if you want to use, say, some particular data mining algorithm, so how that algorithm can be used in order to extract some maybe trends in the data, or some knowledge in the data. But conventional, say, data mining algorithms cannot be applied on the sensor technologies or IoTs. So we have to talk of something called distributed data mining. Maybe distributed data mining will be the future. You can say a research area where people will be talking of how distributed in distributed way algorithms, they can be executed on different such constraint devices, and accordingly we can integrate the results later on.